Alright, so today we're going to be doing 6.5, which is going to be proving two functions are inverses. So we learned about what an inverse is yesterday in 6.4. We learned that an inverse relation is any time that you switch the elements of x and y, whether it be in the form of an equation or if it's an ordered pair, you're switching x and y. And of course, if you switch x and y around, you're changing your domain and range as well, because domain is directly tied to your x and range are directly tied to your y values. Now you also learned on Monday and the days before how to compose two functions together, to put one function inside of another function. And that is going to be a tool that allows us to check if functions are inverses. Now the rule states that if you compose two functions together both ways, so one function inside the other and then that function inside of the other, that if the answer comes out to be just plain x, that in both cases that means that they are inverses. So let's go ahead and try it out so you can see what I mean. I'm going to make one a little bit bigger so we can see it, throughout the whole room. And I can make two bigger as well. All right. So number 1 says verify whether or not f of x and g of x are inverse functions. I'm going to keep the f of x in blue and I will do the g of x in red. That way you can follow what's going on. So they want me to do f of g of x, so I'm going to take the f of x function and I'm going to be plugging the g of x function into it. So as you can see here, I rewrite the f of x function, leaving its x blank. Everyone see what just happened there? Everyone good where I got 2 parentheses plus 3? Now in that function, I'm going to plug the other function in. And once you do that, you're now going to treat this as one big function, one cohesive function. So how would I simplify this? Very good. Distribute. I get 4x minus 6 plus 3, which simplifies to what?
4x minus 6, or 3.
Good, minus 3. So did the answer in the end come out to be just a plain x? No. So I can already verify that these functions are not inverses, because they both have to come out to be x. Both scenarios have to come out to be x. But is that possible for them both to come out to be x at this point? No. So I don't need to do the other part of the problem because I've already verified that it's impossible at this point. Now, because we're doing notes and I know what the answers are going to come out to be, it's okay that we just move on. But if you're on like an SAT or ACT, I recommend checking it both ways just to verify that you didn't make a mistake. Does that make sense to everyone? Okay. So now we're going to go ahead and try number 2. So first thing I'm going to do is I'm going to rewrite my f of x function, and I'm going to leave the x blank to be filled by the other function. I'm going to make myself some more room because that was a little close. Just like that. And inside that function is going to go the g of x function. So the g of x function is the square root of x minus 6. Now we can just simplify it as if it's one function. So what's going to happen with the negative 6 plus 6? Good. And we're left with the square root of x squared. What do we know about squares and square roots? Good. They cancel each other out. So my square cancels out my square root and leaves me with f of g of x is equal to just x. So is there a possibility that these are inverses? Yes. So we're going to have to verify it by now composing the other way around. We're going to take the g of x function, and now we're going to plug the f of x function into that function. So f of x is going to go into where the x was in the g of x function, as you can see here. Now we're going to treat it as one big function. So what's going to happen with the square and the square root? Cancel out, which leaves me with x plus 6 minus 6, which simplifies to just x. So are they inverses?
Yes.
Yes, they are. So far, so good? Cool. All right, moving on then. We're going to go ahead and try 3 and 4. I can make these a little bit bigger for you so you can see better. All right, so number 3, Once again, I'm going to color code these. I'm going to do the r of x in blue. I will do the s of x in red. I'm going to rewrite my r of x function, leaving all of my x's blank. Yes. Yeah, sure. So in that other function, I'm going to plug the s of x function in, just like this. Now, what's going to happen to the 4's here?
Cancel out.
They're going to cancel out, and that's going to leave me with r of s of x is equal to x minus 6 plus 6.
So do black.
These cancel out, and it just comes out to be x. What? That's it. Now we have to do it the other way around. Now we take the s of x function, and we leave the x blank. And what are we going to plug into that s of x function? Good. Which is 4x plus 6, right? How would I go about simplifying this new function?
You would divide the.
Oh, this should be a plus sign. There we go.
Oh, first you cancel out the sixes.
Good, so the 6's cancel, which leaves me with 4x over 4, which gives me, so are they inverses?
Yes.
Wait, this is just, it seems way too easy.
Yeah, the only thing I would say that's hard is there's a few problems on your homework that have slightly more algebra steps, but they're not, the concept is just this simple. So let's go ahead and try number 4. So for number 4, once again I will color code. We're going to rewrite the m of x function, but again I leave my x blank, and when it's just a plain x like that, you have to put parentheses there. In that function is going to go the n of x function, which is 1/6 x. What is 1/6 times negative 6? Negative 1. So negative 1x, is that the same as regular x?
No.
So are these inverses? No. But like I said, if I were on a high stakes exam, especially since this is so close to x, I would compose it the other way just to make sure I didn't make a mistake. Make sense? Okay. So we don't have to do this because we already determined the answer is no. So now we're going to move on to number 5. I'm going to do it in blue and in red. I rewrite my f of x function, leaving the x blank. In that function is going to go the g of x function, which is x, or 8x minus 10. What's going to happen with the 10s? Which ultimately leaves me with? So is there a possibility that these are inverses?
Yes.
Yeah.
So we're going to have to try it the other way around.
Pretty much.
No, we had a few that weren't. What's going to happen with the 8s?
Cancel.
X plus 10 minus 10?
And the 10 cancels with the x.
So are they inverses?
Yes.
What do you think? Easy?
Yeah.
Yeah, I just